All right, we're recording, and we're not doing triple integrals. We're doing homework questions. So, give me a section. 14.6, question 7. I could probably do that. Resume. Oh, okay, sure. This one? Yeah. Yeah, it's just line equations. Hmm. Hmm. Okay, I see. So yeah, they have these negatives. So you're saying the positive is not it? D. Oh, okay. Well, if you know what to do, then we're good, right? Okay. So yeah, let's get a blank paper out and work on this one. That's what you're wanting me to do, right? Perfect. Now let's do it. So I haven't even read this problem. So I got surfaces, this and that, and I got a point. It says parametric equations for a line that's tangent to the curve of the intersection of the surfaces. Okay, so we're wanting to know when they're together, essentially. What I'm going to say is, first off, you can just like mush them together, right? So in a way, I got x, y squared, 2z is equal to 8. Then I have x equals 5. Well, if x equals 5, right? So far, so good. Like, that's the more obvious start to this because it says intersection. It means like mush them together. Combine like terms, I guess. Yeah. So this is my intersection between the two, and it's just a curve. In fact, we can graph it right now. X, Y, and Z. If I move this over, it would be a parabola upside down. Y and Z, something kind of like this, and it's like a tunnel. So it's like a tunnel. Cool so far? Awesome. That's the intersection, at least as far as I can tell, or something like that. I don't know. And it says now we're needing a line tangent to this curve, and it intersects at that point or at that point. So is this point on the intersection? If I plug in right here a 1 and a 1, would I get 3? No? Yes. See, like, I can't plug in a 5 because there's no x anymore. Yeah, if I plug a 1 and a 1 in, I get a 3. Right, right. The 5 is already kind of gone, right? Because we already did that. So it's like pre-computed. So 5, 1, 1. So 5 for my x, 1 for y, 1 for z. It's like somewhere. I mean, it's not the scale obviously, but it's something like on the edge over here. Okay, so that's what we're looking at. Now they're wanting a tangent, a tangent line. Am I correct in thinking this? And so tangent line would be like something like this, trying to just barely touch it. Like here's the curve, and it's like right here, and I'm doing this basically. Am I correct in my thoughts? Okay, cool. So then I want derivatives. Yeah. So if I did my line equation, it's pretty easy. But I know that my slope would be like y prime essentially, or just derivative. What I have here is a 2D version. It's kind of like already done without going too like crazy on you here. Wouldn't I say this? Again, z, and that's a 2. My z's always have a line, okay? So, or to make a better and easier derivative, I could do this. So z prime, 0, and this dude, 2, comes down. I just get this guy. I'm cool with that? What's my y value where I'm looking? Like, what's the y value supposed to be? 1, right? So that's kind of like my slope, I guess, in a way. So here we go, y minus y1, m, x minus x1. Okay, whoa. I can't say y, can I? I can't say y. I got to say z because everything's in z's and y's. So z minus 1, that's it, z1 technically. My slope was a -1, and this is a y minus y1 is a 1. And let's do a little bit of math. So distribute, yeah, add 1. And so I got z is equal to -1y plus 2. Do I have something similar to that already? And see, you see in a problem, this is not bad. This is not bad. But this is my answer. But they have it in terms of t, right? Yes? I know what you did a different road. This is a completely different road than what you did. Am I right? But are you seeing the process at least? I'm going to try to get your negative. Do I have a negative? Okay. I can go back and do it your way. But do you see how I have a negative already? Just a thought there, right? I want to make it parameterized. Is that a word? That'll be good enough, right? I want t in there. I want to go ahead and include t somehow. So this is kind of like my answer, but I need to like do some t's and stuff. Okay. So let's go to the very top and write down the things I know. I know that x equals 5. I also know that I have this guy right here. Z is equal to -y plus 2. And now I want to put some kind of t's in there. So I'm going to just make some stuff up if you don't mind. What if I said that y is equal to t, and so therefore z is equal to -t plus 2, and then x is equal to 5? Is this one of my options? No? Dang. So yeah, if you're looking at the answers, basically, like, because we have to pick the best answer. Like this probably still works, but we have to kind of work it a little bit, right? So that didn't work. Let's go back and see what they have. If I'm saying that my y is equal to 1 plus 2t, let's just say, because I have to kind of follow the rules since I did not do it the proper way here. Let's now plug that in. Okay, so I got a -1 minus the 2t, and then plus 2. And so then combine like terms. Yeah. Is that what they have? And again, x equals 5. Already knew that. So I got your negative. Yeah. But I almost had to use their answers to be able to get to what I wanted. But do you see that it's possible that maybe like I can at least say that they're not incorrect? Okay, good. Now I want to do it your way because this is confusing, isn't it? You can, yeah, you can just admit it, bro. It's fine. So brand new, fresh start. Let's just do it the way we need to do it, right? Like you were telling me, the answers should be x is equal to x naught plus at. Again, a is like x prime, basically, blah, 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 right? My slopes. So let's do that. And I'm just going to rewrite them. This is the actual way to do this problem. Okay. Now, I can't just like toss them in. I need to get that intersection still. And so plugging it back in, we had y squared plus 2z was equal to 3, I think. Was that the intersection that we had plugged in? So from here, I need to take some derivatives in terms of y and z. I guess not x because it doesn't matter. So yeah, let's do in terms of x. Oops, eraser. Let's call this, we got to call it something. Do you mind if I call it something? I'm going to call it f. So then I got fx, right? This will be my derivative in terms of x. What is that going to be? Boom. So my y, what would I get? And z? 2. Okay, so I got these guys right here. Now, that's your positive that you were thinking. And that's scaring me now, right? Because I got a negative last time. Why is it positive this time? Well, let's do some math. I'm a little nervous, but we could try. I can't plug this slope in. It's almost like I need to plug in the value for y. And the point that they gave me was y equals what? Boom. So then I should get a 2 out of this. So in a way, I've got 5 plus 0t. I've got 1 plus 2t, because 1 times 2 is 2. And then I've got 1 plus 2t. And that's what your proposal was. Yeah. So why is it that, where do they get the negative from? It's a good question. Like, what did I do wrong here? That's the point. Because I know I did it right the other time. I get that. True. True. Um, when we did, I know I already erased it. I think what we had done was I solved for z. So instead of going down this road, I had done z was equal to negative y squared plus 3. And that's when I said like z prime 0. And then I plugged in my 1. So z prime is a negative 2, which would mean the answer that I want. Yeah. But I'm not doing z equals, am I? Is that how it should be? Go ahead. Gross. I guess that is a way to do it. So, thinking out loud right quick. So then my gradient would then be 1, 0, 0. Yep, yep. And then we're cross prodding it because we're going to like that unit tangent vector junk. I like my algebra way. Personally, I like the way I did it first. Okay, yeah, let's do it that way for a second. So grad f, we would get a 1, a 2y, and a 2, and then I'm going to cross it with my grad g, and I have to plug a 1 in right there. Okay, so then I got 1, 2, 2 cross 1, 0, 0. This is sloppy. I'm so sorry. Not really. So zeroed out 0, 0, 2, and this was the positive j. No, no, no. It's a k. It's a negative k. You're right. Gosh, man. This is why I write this stuff down on my note card. Zeroed out, and then finally 2 times this. That would be a positive j. And so my result would be 0 to negative 2. And there's your negative slope. I think that's probably what they want you to do. Did you do the view example thing? Yeah. Yep. So there's your slopes, and then you can go back and do it the cool way. Or you could do it the algebra way, which was confusing. Good question, though. You see what strategies we can take? Okay. Yes. You're good at that now. Give me another one. Question 16. Sweet. Oh yeah, I love this stuff. Oh no, I don't love this stuff. Did I not delete it already? Oh, okay. Let's just figure it out. Is that okay? I don't mind looking like an idiot. Okay. So y'all all have part A down, yeah? Yeah, that's the easy part. But I still need to do it. So I'm doing this. So I'm doing grad f, and so in terms of x, I would get the negative ex cosine y, and then in terms of y, that cosine goes to a, well, it's negative cosine. Sweet, sweet, and that's it. And again, we're plugging it in and plugging in 0, 0. So then we get negative 1, I believe, and then this would just be 0. So those are my slopes for the linearization. I think then I got negative 1 x minus 0, 0 times y minus 0 is equal to 0. There's a piece that goes in the front. For their linearization? Yeah, that's for the maximum. That's the second part. Oh, that's what I'm missing. That's what, yeah, because it's equal. Okay, yeah. Is it equal to that? See, this is the formulas I don't have written down. I equal that value, so that would be f at 0, 0, or do I just add it? It's added, okay. Thank you. And this is why I write it down my note card. Plug it into the original 0, 0, I got -1 out of that thing, I think. Okay, so negative x minus 1 equals 0, but we don't do the equals because it's L equals that stuff. Right? Okay. Well, that was a lot of lame conversation for nothing. Okay, so yay, we got that part. Now what? Right? And so y'all are going to remind me, because you already wrote it down in your note card, about the formula here. So my error is less than or equal to, was it 1/2? Um, no. This is good. This is good. So it's times this thing and then plus. Okay. That part squared, but not the m. Okay. The m, I believe, is going to end up being a 1 because whenever you're just looking at stuff and derivatives, it's either going to be a 1 or a 0 or something. Just a guess. Just a guess. We'll go from there, okay? I think this part is a more confusing one right now. So we're going from 0, and it has right here absolute value of x, absolute value of y, right? So what I'm wondering is, couldn't that be x minus 0, y minus 0? Do you see that? Like if I put 0 here, you wouldn't really write it, would you? Wouldn't you then get what these guys are immediately? So in a way, it's like I'm like substituting like this. Oh, they gave us m? Oh, okay. Well, I thought it was about a 1. So yeah, good point. So this part here is the 1.08, and this part here was a 1. And so like this times 1 would be the 1.08. So I was really close. So it's 1.08 times 1, I guess. 0.0. Right? Okay, cool. Now, yeah, I get you. And then we have a 1/2. Let's just see what happens with this. I need Desmos. Desmos to the rescue. Da, 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 da. It's still like I kept solving forever, and they're like, okay, plug it in. Wrong answer. Yeah. I remember with this question, I moved forward. It was like, you gotta take that and then subtract the absolute value of x from it, and that's your answer. So I tried that, still got the wrong answer. I'm like, bloop. Yes. There we go. Oh, I didn't want to do next question. Can I do back? There we go. So, right, it worked. The reason why this one happened is because it gave you this extra little bit of information. Notice again that this little e thing right here is 1.08. Like, again, substituting. And then this cosine right here is, again, just a 1. Now, I had thought it was going to be about a 1 just because the way things looked and the way things we were, like, plugging in 0. What do you get? You get a 1, right? So, but they said it was off by a little bit. That's fine. Again, I would expect my change in x to be 0 technically. So why did they give me a little bit of number? Because it's not perfect. That's the error part, right? So having not 1 here is exactly the point, in a way. Is that good? It's not just that though. That I want to stress because that's only that part. Like, well, I'm only like for the folks at home right here. I'm only saying that's 1.08, and the cosine right here that's a 1. Yeah, yeah, yes. It would. Yeah, you plug that in. Yes, that's why I stressed that it was not just 1.08. It's 1.8 times 1. It's like two different numbers in a way. You got your e to the x. You have your cosine. Yeah. Good. Okay. Awesome. Give me another one. Oh, triple integrals. Okay. You're good? Oh, Lee's gonna look for something. He doesn't want triple integrals. Okay, cool. Triple integrals. Let me just keep checking the. Yeah, we got video, we got audio. We're good. I have to keep checking that. Yeah. Yeah. I think that was like 2 days in a row that bad things happened there. So, get rid of that. So I will eventually, not this semester, but if we do switch to a permanent solution here with this platform, then yeah, I will be re-recording it and making it professional, just like my other calculus videos. Do y'all say the other calculus videos are professional? Not really. Yeah. True. Well, yeah, that's exactly right. They're more organized, but it's still me complaining a lot. Complaining a lot. Gosh, again, I can't believe I have to do this. Yeah, sorry guys, but that's part of the flavor. That's part of the character. So we've already seen this before, right? Its volume is triple integral. D stands for domain, as far as I know. I don't really know honestly, but I think it's domain. See, it says D in space, just domain, I guess. R for region. Yeah, exactly. Those are my numbers. And see, they're already jumping to the fact that we're going to have these functions here immediately, which is nice. That means that they're not going to baby us. They're just jumping right in, and that's excellent. Okay. Now, again, traditionally we go dz, dy, dx. That's a good way. I want to scroll far ahead for just a moment and show you more of what we're looking really far ahead towards. This is all rectangular, right? But we did polar last time. You're not going to you will see it again. So I'm going to scroll ahead, way ahead. That's all rectangular stuff. Is that rectangular? Yes, it is, because it's still dz, dy, dx kind of stuff. Okay. What applications? Where's my spherical and all that stuff? I know I shouldn't go scrolling ahead here, but better. So this is not today, obviously, but this is an extension from polar. So we did polar is 2D, but now in 3D would be spherical or cylindrical, and those formulas and stuff are going to be great fun. Anyway, so this is what we're looking forward to eventually. Right now, easy stuff, I guess, and ignore all those other formulas. Just totally ignore that section. This is nothing. Average value, we've already seen this as well. You're just dividing by the volume in the bottom. No big deal. All right. I'd almost want to say that's a you-do. Actually, you know what? It is. That's a you-do. The very first one, I'm not even doing the first triple integral because I know you could do this. Remember that we're doing the x first here, yeah? And then dy and then dz. In the meantime, I get some coffee. Would it be creepy if I came up and stared at y'all while you're doing this? Oh, you're done already? Gosh, man. Oh, before class, you gave it away. I was gonna make like a joke about how awesome your brother was, and now you are following his footsteps. Like I go through the whole process, but then you just blew it. You cheated, bro. No. He did? Oh, well, I guess I can poke him about that. Yeah, that'll be really fun to bring that up. I mean, he'll be here in a month, less than a month. Yeah, that'll be good. Is that the I'm done and I don't want to look cool face? Oh yeah, you did. I'm sure you did. It is a little weird. I personally want to rearrange it, but I'm picky like that. In fact, that's what I'm gonna do. I'm gonna throw y'all off and not do what they're doing. I'm gonna do something else. Yeah. Yeah. Oh yeah, definitely. Um, the reason why is because they don't interfere with one another. So they're multiplied, but the z won't affect the y, and the y won't affect the z. Um, yes, yeah. And I wish I could give you a criteria for, hey, when can I rearrange it? I don't think I can give you a perfect one, but like guideline wise, if they're not affecting one another, it should be fine. I would get nervous around if you got like a YZ and then you like had to integrate it. That I don't know because they're still multiplied, or even this might make me more nervous. Um, so I don't have a perfect criteria, but I will do it here just because it's funny. Also, it's mainly because these are all numbers, and if they're not all numbers, then you can't rearrange it for sure. If they're because of functions and stuff, it's all weird. So let me be weird, and I'm gonna do y cosine of z, and I'm going to do dz, dy, dx because I'm just strange like that. But I want to make sure I do this right. My z was 0 to 1. Am I correct? Okay. That's strange. I don't like that, but it'll be fine. My y was 0 to 3 pi, and my x is 0 to 2 pi. Yeah. Okay. All right. So I'm going to try to write tinier. When I integrate in terms of z, what happens to this cosine? Becomes a sine straight up. So I got just a sine of z from 0 to 1. And this is where I don't like it. Do you see? I'm plugging in a 1. It's not arc sine. I'm doing sine of 1. Here, look, I'm glad I have this up. Sine of 1. Do you know what I mean? Now, what you're thinking is like the arc sine is pi over 2, right? See? You're right there. It's just I'm just plugging in a 1. Let it go. It's just a number, isn't it? And it's not because I'm rearranging. You're going to have to do that eventually anyways. So I'm going to let it go and do what I need to do. So then I got double integral of y times sine of 1 of all things. And that's just a number. So I'm going to pop it out to the front. Sine of 1, double integral of y, and now dy dx. What's my integral in terms of y? Yes. Yes, exactly. 1/2 y squared. Yep. You're good. You're good. It makes me wonder, like, this is x, and it's like, is it purposely throwing me off? Because I would love to throw a pi in there, but it's like the only place that you know what I mean? And look, right now, I'm going to plug this in, getting like pi squared. So, go ahead. Oh, it's a 3 pi. I'm sorry. You're right. 3 pi. You're right. You're right. I'm messing you up on purpose, and I'm sorry. But I'm not sorry. I'm doing it on purpose. So yeah, that's a 3 pi. So then I technically have 9 pi squared. I already have the divide by 2. So what am I doing there? I have the 1/2, 9 pi squared, and then I have a sine of 1, integral of 1 dx. And again, that's just going to be an x. And I plug in the, what is it, 2 pi? So 1/2, 9 pi squared, sine of 1, and then 2 pi. So in the end, these guys cancel. Pi cubed, 9 pi cubed sine of 1. Flash the answer, bro. Because, like, unless they messed it up, they could have. I did a weird. Oh, it's just a weird problem, and they're trying to throw you off. Mm, true. That's true. Well, okay, true. Think of it like this for a second. You have 3 different numbers flying around, and most people at this point aren't as dyslexic. I am. It's okay. Me too. So I am. So like the point is that they're trying to make your eyes go weird. Like, oh, obviously that'll go into the cosine, but it doesn't. So they're just making it purposely stupid. See, even this commentary is me being bad and saying bad things. Are y'all good though? And notice that I rearranged it; it was fine, right? So it's okay to do that, especially when you have just variables. Um, Now this is not so fine. See how we have functions? Ooh, an infinity. I know, right? Hey, how about every problem's a you do? No. Let's go through it. So this guy, we're going to start with an x. That's not too bad. So when I integrate in terms of x, what do I get? Cool. Hey, we're not there yet. We're not there yet. I'll deal with that problem later. So I plug in the 2t. That one's easy. And then I have e to the negative infinity. And you might be saying, Chad, you're not allowed to plug in an infinity. Yes. Yes, exactly. Yep, that too. Yes, exactly right. They're doing this all on purpose because they're like, oh, there's 3 now. And yeah, you're right. Anyways, back to the infinity. You're correct. E to the negative infinity is going to 0. But can I use Desmos to help me there? Yes. So you do e negative that 0. It's so nice when we have Desmos up and here to help us. So now I have to integrate this in terms of t. What do I get there? Very good. Very good. Very good. From 0 to ln of stuff. Yeah. Ooh, really? Well, that's nice. But it won't cancel immediately, will it? I hope you didn't cancel it immediately. If you did, you need to stop. Also, when you plug in a 0, you actually do get something this time. You get e to the 0. Right? And what's e to the 0? Mm-hmm. So this 2 is in the front. Do you remember your log rules? Your log properties? No. Squared, very good. It moves up. Yes, exactly. And so this is secant squared technically now. I don't like that notation, but it'll have to do for now because I'm just doing this. Okay, nice. Have you noticed some? I'm not done, of course. Have you noticed something about my laziness? I just stopped doing like DVs and DT. Oh yeah, what's up? Hmm. Oh, you got me. You got me. You got me. Gosh, man, bonus points or something. I don't give those out in this class, but you know, if I had them, good job. So you're saying this a 1/2 because we're doing integration. Ah, okay. Oh, me too. Me too. I mess it up. It happens all the time. That's why we take our tests collaboratively. Anyways, did you notice that I was kind of lazy? I drop some things once in a while and stuff like that. It's because it doesn't matter. You know what's going on. As long as you don't make mistakes like the orange, everything else is fine. So this, I know that we've done this before. I know we've done that before in pre-cal. No, 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 no. That's too much work. It is tangent. I believe it is. Now, I don't know 100% if it's a tangent or if it's a negative tangent. Wait, how? Yeah, they don't even like secant here. Just let it go. I think it's tangent or it's either negative tangent. So if it's wrong, then we can put a negative sign in the front. We'll see. I think it's tangent. I think we'll see. Anyways, so we have integral of tangent squared, which good thing I wrote that down on my formula book. No, no, I did not. I thought so too. No. So it's going to be a 1/2 in the front. I have a negative v plus tangent of v. That's lame. What? Oh, because secant squared goes to a tangent and then the 1 goes to a v. You know, so they probably said this to this. Oh, clever. And I was saying, nah, man, nah, I ain't doing that. And you were right the whole time. Hi. No, no, my pride got in the way. I'm sorry. I'm sorry. Yeah. Um, tangent. When I plug in pi over 4, I should get 1 indeed. Very good. And I get a 0. Plugging in a 0 for tangent, we get 0. Yeah. Um, I'm just trying to get you. There's so many gotcha moments so far today. So they got negative and positive. Yeah, we got it. That's the answer. Cool. So the bigger question: could I pass my own Calculus 3 exam? Yeah, well, Um, some of y'all have had engineering classes with us, right? Not you. That's fine. Connect. Yeah. Yeah. How many do you get right on your exam? Yeah, lucky is half, mostly just a zero, and then he grades it later, and you get, oh, I passed. Yeah, right. Yes. Hmm. Oh, I see. Well, just like engineering classes, Cal 3, we strive to do bad math. So, um, we still got some time. So it says find the volume of this thing. Um, we have this equation, we got this equation, and I don't know. I guess we're just going to mush them together somehow. I think this is the plane that's on the top. It's like cutting out this wedge. Basically, that plane is making this thing. That's actually a plane. The cylinder part is this part here. That's the cylinder part, and it keeps going. It's like a parabola thingy. They say cylinder simply because it's 3D, but it's just a parabola. Do you see what we have right now? We have a top and a bottom, essentially. And volume is always going to be triple integral of 1 dv. So we need to kind of make our limits work for this, right? And I'm going to do dz, dy, dx initially, hoping that that will be good enough. Okay. And so I need to fill this whole thing in. After this, it's easy street. So I need my z's. I basically need, these are the bottoms, right? I mean, I know they're on the bottom. And this is the tops. So I need the z bottom. Looking at the picture, what would be your z bottom? 0 indeed. Yep, this is first octant. It's only showing first octant, at least. I can say that. So z equals 0 is this. It's this like plane right here. Now I know we're going to take only part of that plane here soon. That's that whole cylinder thing. But until then, 0 for sure. What would be the top? Perfect. I love it. That's exactly right. It's at the top. This plane is cutting it at the top. Rearrange it, get the z equals. Very good. Okay. I already noted that this looks like first octant. Just a guess about what my y value would be for the bottom. Yeah, good thing I'm circling like that. Now, I need to somehow use this y right here. Okay, I need this part. Yes. Um, yeah, that I don't know about you guys, but that looks like a piece of junk. I'm gonna keep cruising this tiny bit here. We're almost done. Bottom for x. Well, you got the easy answer. So now where's this part? Where's my x value right there? If y equals 0, x would equal, okay. And we got a number, which means we should be finalized here. Now, that will work. That will work. And I'm going to prove it to you by cheating a little bit. I'm so sorry I cheat so badly all the time. Okay. Desmoscom. So integral 0 to 4, integral 0 to the square root, negative x plus 4, and then integral 0 to 2 minus y of 1 dz dy dx, 20 over 3, 20 over 3. We got it. So I got to say, and I would totally recommend this on a homework, that did I set it up right? Did I set it up right? Because if you go and do this triple integral, 5 minutes, 10 minutes, whatever it takes, right? And it wasn't set up right, you just wasted your time. You just wasted your time. So if you can, if there's an easy way and it doesn't work, not every problem's like that, of course. But if you can at least try and see, hey, does this work? Now you know that it works. Now you should go and actually do it for reals. Okay? But timeout. Do you actually want to integrate with that square root up there? I don't. Nope, there's an easier way. So I forced it into dz dy dx. I forced it into that. You don't have to do that. So let me give you an equivalent, and we'll test it in Desmos as well. So I'm going to say dz dx dy. Now I'm doing this because x equals right there. And so the z's are the same. That's fine. And then my x's are from this to this guy, right? Just plug it in. And then I'm saying my y. So what would be the y value right here? And if you think about it, if x is equal to 0 right there, if that's a 0, and I solve 2, exactly. Let's test this one. I want to make sure. If I'm going to spend the next 5 minutes doing it, is it going to be okay to do it? But now I'm happier with this one because I don't have a square root, and it should then be better. Oh, dx dy. Yep, same thing. Cool. So equivalent, yet easier. And so that's what I'm going to do now. I'm actually going to do it by hand. We have 8 minutes. We should be fine. So, but are y'all getting the bigger picture here? Did I set it up okay? That is a huge question. I know you can't do that on the exam right now, but at least you can do it on your homework so you don't waste time. Wasting time sucks. You got other things. Who in here has other classes besides this one? Oh, all of you. I see now. Right? So don't waste your time. At least see, is it at least close? Okay, let's do it. So now that I wrote all over darn place, I'm gonna erase it if you don't mind. Let me rewrite it on this side tiny, and then so triple integral 0, 0, 0. Some other strategies going forward is that you can write at a 45-degree angle, and that way you can scrunch more in there. Things you learn over time. Okay, so that's my integral. Let me erase all this junk and get some room. Go away. Okay. And I don't want that right there either. We're going sideways. Okay, integrate in terms of z. What's my integral of 1? Right, it'll end up being that way. Integral of 1 is z. Plug it in, and you'll get the 2 minus y, dx dy. Yep. Now I'm integrating in terms of x. What would I get there? Yeah. Yeah, x yada yada. I love it. That's exactly right. X yada yada. And then I could plug that in for my x. I don't know where that little stray thing went. 4 minus y squared, 2 minus y dy. What do you propose at this point? Sorry for the folks at home. I'm going to be straight with you. You can. You can, and it's gross. I don't want to do U sub. Come on. Come on. What should we do? I love these moments because I'm almost teasing y'all. Yeah, of course. Of course, FOIL it out. Yeah. So we got 8. I know. At this point, we're like, FOIL, what is that? 2 negatives make a positive. Come on now. Isn't that way easier to integrate? That's happy days right there. You're like, man, I remember Calculus 1 days. Isn't that going to be a 2y squared? 2y cubed over 3. Y to the 4th over 4 from 0 to 2. 0 would cancel everything, so we get 16. 8. 16 over 3. And 16 over 4 is a 4. Yay! I didn't test it. I didn't test it. I'm sorry. Does it look good though? Okay, good enough. I see no calculators because we don't need them. Good though? Okay, cool. That was good. That was a fun little problem. Are we done for the day? We got 3 minutes. Let's just see what's ahead of us. Another one. We'll leave it for next time because it's another good fun one right there. So any questions? Good to go? Okay. And if you got more homework stuff for me next time, because isn't it the due date now is Monday, not tomorrow now, right? You good with that? Awesome. So then if you have last minute questions, we could do that tomorrow or on Monday as well. Cool, guys. Thank you for hanging out. I'll